Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 25, 2025, about 3 days ago. It shows that with the right post-training, a compact multimodal model can more than triple its success at finding targets in 360-degree scenes, boosting humanoid object search from 14.83% to 47.38%, and humanoid path search from 6.44% to 24.94%. The paper is titled, Thinking in 360 Degrees, Humanoid Visual Search in the Wild. And, as we will see later, the implications for embodied reasoning are pretty striking. Alright, Figure 1 lays out what humanoid visual search actually means. The left globes illustrate a humanoid agent whose head and eyes sweep over a full sphere, with a narrow foveal field of view that must be aimed toward a target. The diagrams emphasize that head rotation changes the focus area and eventually the body movement direction. On the right, example panoramas show two task families: humanoid object search, like finding pink shirts or a clock, and humanoid path search, like locating where to move in a subway station or airport. Well, Figure 2 explains how the model learns this humanoid visual search behavior in 2 stages. Stage 1, on the left, uses annotated 360-degree panoramas to train the multimodal model to map each view to a reasonable head rotation, using standard supervised learning. Stage 2, on the right, adds multi-turn reinforcement learning, so the agent learns a strategy. It strings together observations, thoughts, and actions, rotating to explore until a clear cue appears, then submitting a final direction. Alright. Figure 3 shifts from the training pipeline to what the benchmark actually contains. The top panels show that most scenes come from large-scale retail spaces and transportation hubs, with each major category further broken into subtypes like malls, transit stations, and museums. The bottom left chart lists object instances, dominated by signs, labels, and furniture, so agents must parse dense clutter. The bottom right plots define difficulty levels, revealing that many humanoid object search and humanoid path search tasks are medium or hard, with partially visible or even invisible targets and tricky language cues. So while Figure 3 detailed what is inside the benchmark, Figure 4 shows how training generalizes across task families. The left chart reports humanoid object search. In task training, in green, clearly beats the baseline in blue, and cross-task transfer in orange lands in between, especially on hard cases. The right chart tells a similar story for humanoid path search, but transfer drops sharply on hard and extreme scenes, which signals that high-level spatial skills do not yet transfer well between objects and paths. Alright. Table 1 turns the benchmark into numbers and confirms how big the gap was and how much training helps. The left table shows that small open-weight models start below 20%, while Gemini 2.5 Pro leads proprietary systems, and the fine-tuned H versus S3B clearly tops everyone on humanoid object search and matches or beats them on path search. The radar chart on the right summarizes this, showing H versus S3B dominating easy and hard object search and competitive performance on the toughest path cases. So, while Table 1 compared different models, Figure 7 contrasts how they search. The left panel shows that with Gemma 3.4b actively rotating within the panorama beats passively reading the whole panorama, for both humanoid object search and humanoid path search. The right panel compares static two-dimensional methods to embodied search. Disembodied methods reach nearly 90% on the flat V-star benchmark, but crash below 12% on the embodied H-star bench, whereas H versus S3B still scores about 38% there. Okay, Figure 6 dives into how the trained agent behaves over time. The left panel shows that most gains come in the first 3 to 5 turns, and reinforcement learning pushes both humanoid object search and humanoid path search curves noticeably higher, especially early on. The right panel plots context length, and shows that giving the model around 2 to 4 past steps of history yields the best success, while very short or very long contexts slightly hurt performance. So the big picture is that active humanoid visual search in 360-degree panoramas is both feasible and still very hard. Compact multimodal agents can triple their success with tailored supervised fine-tuning and reinforcement learning, yet they still lag far behind human-level spatial common sense. That gap defines a rich frontier for embodied AI. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.